Hello everyone! Today we'll be working with the forces and movement simulator and relate them to Newton's laws. So, my name is Jimena and today I will be explaining thoroughly how these four simulators work and how and why they are related with different Newton laws. So, to begin with, let's do the net force. Here you can activate these parameters so you know how much is the sum of forces, how fast it goes, and like the magnitudes. So here you can move these little guys that represent the different amount of force that it's going to be applied to the cart, and depending on the result of the sum forces. Okay, yeah, you can see that's the direction it's going to take. Because here we have 150 and here we have 100 newtons. So this in a Cartesian plane would be 100 minus 150. I'll have minus 50, which means it's going to the left. So if we get the same amount of force on both sides, it's not going to move at all because the sum of forces it's equal to 0. Then if we want to put one little guy and a tough guy, we're going to get, so it's quite obvious that the cart's going to move towards the big guy because it's the one who's applying way more force. And then we can try it. And there we go. Red team wins. So, what we can conclude about this is that when the net force is 0, the object does not move at all. And we could say that this simulator is related to the first Newton's laws, as if there's no movement, there's no force applied, so there's no movement. There's no reaction to it. Okay, moving on to the next one. We have quite particular combinations for masses, but well, here we have more variables. We have forces, for example, I don't know, they'll have like the magnitudes, the masses, and these two to measure how fast it's going and how long does it take. So let's say we have to move a 50 kilogram box and we apply 50 newtons. Okay, we can see that it's moving, and as we're applying a constant force, then it's accelerating. But if we remove this force, as there's no friction, it continues going on smoothly. But on the other side, if we apply a negative force, it starts to slow down. We can't see that here. So this one is also related to the first law of Newton, which establishes that as long as an object does not have any other movement, as long as the object does not have any other modification, it will remain moving. And the second law, which is about the acceleration being related to the applied force. Now, thanks to the chronometer, we can perform some other calculations, like if we go 100 newtons, how long is it going to take to reach 20 meters per second? And we can see that it's accelerating a little bit, little by little, but it's getting somewhere, it's getting there. Okay, yeah, it might take a little bit longer than expected. Okay, there we are. Okay, yeah, that's it. Then we have the friction simulator. This one might seem quite similar to this one, but the only difference is that here we were ignoring the friction that we had using the skateboard, and here we have to move the object from the floor, taking into account the friction coefficient. So we have forces, some forces, magnitudes, masses, and the chronometer, and a measure of how fast we're going. Okay, sounds good. Let's say we begin with 50 kilograms, one little guy, and 150 newtons. So we can tell that the friction coefficient is kind of in the middle of the parameters between nothing and a lot. So we get that the friction force is about 92 newtons. This force is kind of pushing the object backwards. And in the end, we have 58 resultant newtons. Oh, did you just die from exhaustion or something? Well, I'll have to check that later, but poor little guy, it can have just fainted. Well, I hope he's okay. I mean, we can't really do much about it without him. Let's just revive him. Okay, now if we decide to remove the friction, nothing. It'll be the same thing as the last one with the skateboard, because there's no other force pulling it backwards. But if we do a lot, we can see that it's way too slow for her, because she needs to beat this 34 newtons that she also has, pointing towards her. But in the end, you kind of understand how this part works. I hope he doesn't die from exhaustion again. But last but not least, we'll go on to the acceleration simulator. Oh wait, I did forget something. It is important to think about the relationship between Newton's laws and the simulators, because for example, friction is a force, as we can see here, that is going to be taken into account when it comes to the sum of forces. Then, finally, last but not least, the acceleration simulator. We have multiple variables: the forces, the sum of forces, the magnitudes, masses, how fast we do that, or how fast does it move, and the acceleration we have. This one's new. Okay, so we can see that, for example, let's do 50 again. This one's okay, 150, so it moves. Okay, we can see that it's accelerating slow and steady. It's slow and steady. But if you increase, oh my god, okay. If you increase the friction, it's going to slow down. Okay, there we go. So it's more noticeable. It's going to slow down because there's another force pulling it. But if we remove the friction, it's going to increase its speed quite. Oh, it did a split again. Why is he always doing that? But okay. So the main point about this is that okay. So now let's try with a different mass. Okay. We can see that I don't know 20 200 newtons with this 50-kilogram box looks like this. But if you change the mass for a 200-kilogram refrigerator, 200 newtons, they're going to be the same thing. It's not even going to move. Wait. Oh. So we might have to remove, oh no, wait, remove friction for it to do something. Yeah. So what we know about this exercise is that, oh, surprise mass. Let's see again, 200. So this whole acceleration part is related to Newton's second law about force being equal to mass times acceleration, because you only need to change the equation, rearrange it in order to find A. And it is really useful that you have this thing here. So you don't really have to calculate that. You just introduce your data and wait for it to calculate how fast it's going to go. And overall, that's it for the simulators. I hope it's kind of clear. And thank you for watching this.